So I'm answering questions number 6 and 7 from exercise 9D. So question number 6 says that Jin throws a stone into the air. The stone above the ground can be modeled by this equation, where t is the time in seconds from when it was thrown, and f of t is the height of the stone in meters. So find the maximum height that the stone reaches and determine how long it takes for the stone to land on the ground. So maximum height will be quite simple. We just need to graph this equation on our GDC and find the maximum, so the vertex of the equation. That will be the maximum height. To determine how long it takes for the stone to land on the ground, so we're looking at time, which is t, or our x in this case. And when it hits the ground, that should be when the height is exactly 0. So when f of t is exactly equal to 0, then we will be able to determine where it landed on the ground, how long it took to do that. So I have already written the equation in my calculator, and I have adjusted the window so that it will fit. So I have an x minimum of -50 and x max of 50. I have a y minimum of -50 and a y max of 50. So when I graph it, I can clearly see the graph, the curve of the graph. If you can see that on here, maybe not so clear. So to find the maximum height, I'm going to do second trace, and I'm going to find the maximum, number 4. I'm going to choose a point just a little to the left of the curve and a little to the right of the top of the curve. And it shows me that the maximum x equals 1.93 and y equals 8.00. So that means that the maximum height that the stone reaches, remember x is our time in seconds and y, our f of t, is the height in meters. So the height is about 8 meters when it is 1.93 seconds. Determine how long it takes for the stone to land on the ground. Now, I'm not going to choose the first x-intercept because the first x-intercept is at 0, 0, and that would mean when he first throws the stone, so at 0 seconds, the stone is at a height of 0. So I'm not going to check that x-intercept. I'm actually going to check the next x-intercepts because that is when the stone would then hit the ground after the throw. So I'm going to second trace and find the 0, and I'm choosing the right side. So when it passes through the x-axis a second time, and I'm going to choose that point, and it is when x equals 4, y equals 0. So that means after 4 seconds, when x is 4, then it is on the ground at y equals 0. So that's number 6. Number 7 then, a rectangular picture frame has a perimeter of 100 centimeters. We need to find the width of the frame and the height of the frame and write it as an expression of the area. We then need to plot the area, find the x-intercepts, the y-intercepts, the axis of symmetry, the coordinates of the vertex, write down the maximum area of the picture frame and the dimensions of the picture frame that give this maximum area. So the width and height that give the maximum area of the picture frame. So first thing, we need to write an expression. So we know that the perimeter is 100, and that is 100 cm. So I'm going to write perimeter equals 100 cm. And it is a rectangular picture frame. We are told that the height is what we're trying to find. We're told the width is x, so we'll call this side x. This side is also x. For right now, we'll just call the height y. You could call it h if you want, it doesn't matter. So the formula to find perimeter of any object is to add the distance around the outside of the figure. So if the perimeter is 100, that would be y plus x plus y plus x. So 2 x's plus 2 y's. I'm going to solve this equation, and I'm going to solve it for y because y is our height. So first thing, I am going to subtract 2x from both sides, and I get 100 minus 2x equals 2y. Then I'm going to divide both sides by 2 to solve for y, the height. 100 divided by 2 is 50. 2x divided by 2 is just minus x. And 2y divided by 2 is y. So that means the height, so this was the first part, the height can be written as 50 minus x. The width is x, the height is 50 minus x. So area would then be width times height. So one side of the rectangle times the other side. So I'm going to use my new expression, my 50 minus x expression for the height. And I'm going to multiply it by the width, which was x. And I'm going to simplify that so I get an area of 50x minus x squared. Which notice that is now a quadratic equation because I have x squared and I have an x term, and I am missing the c term. If you think of this as your a term, your b term, and your c term, my c term is just 0. You can write that, but there's really no need to write that. So the next thing, I need to plot this graph. So I'm going to plot the graph, and I'm going to write in my equation, I'm going to write it as negative x squared. I just want to write the a term first, plus 50x, and I'm going to graph that. Now I won't be able to see it very well because of the window, so I'm going to adjust the window slightly. It looks like I need to look a little more to the right and I need to go higher. So I'm going to change the window settings to have a Y maximum that's a bit higher. And an X max that's a bit larger. And I still need it to be much bigger, so I'm going to adjust it again. And the Y max needs to make it a lot larger. And I'm almost there. My Y max, I had it at 500, so I'll just pump it up to 800. All right, now I can clearly see the maximum of the curve, and I can see the two x-intercepts. So I'm going to use that to help me identify some parts of it. So I'm going to second trace and look at the zeros, the x-intercepts, and I'm going to pick a point just a little to the left and a little to the right. So one of my x-intercepts is at 0, 0. And I'm going to find the other x-intercept. And the other one as x is 50, y is 0. I'm going to now find the top of it, which is the maximum, so the vertex, and I'm going to pick a point at the top, just a little to the left of the maximum and a little to the right of the maximum. And I have a maximum that x is 25 and y is 625. And this is the vertex. These were my x-intercepts. And this top one is also my y-intercept because it's y equals 0. So, with all this information, I'm going to answer some questions about the picture frame. So what I can gather from this information is that my picture frame, the maximum area the picture frame can be is 625 centimeters squared. So that's the maximum because that was the maximum of my curve, and that is when x is 25. So when the width is 25, this is the maximum area I can have. So a 25 by 25 picture frame. So a square picture frame would actually be the maximum area. A few other questions about this as I go back to the textbook questions that it was asking. So some other questions it asks is to find the coordinates of the vertex, which we did find that was right here. That was the axis of symmetry then, was when x is 25. That's your axis of symmetry. And that is all the questions were answered for number 7. So that is number 7.